Dear participants, welcome to 5th International Congress on Human-Computer Interaction, Optimization, and Robotic Applications. We are in session 11.2 now. We have 9 papers to be presented in this session. Also, we have 2 more extra papers. The authors will not present their works in previous sessions. Each participant will have 10 minutes to present their works. If you are ready, we can start. The title of the first paper is Parameters Extraction of Miniaturized Metamaterial Unit Cell at Millimeter Wave Applications. Are the authors of this paper here? I guess they are not here. Let me announce the second paper. The title of the paper is
Sir.
Alaikum. Are you the author of the first paper? Yes, Huda, right? Huda Altaya, right?
Huda, yeah.
Okay.
Parameters extraction. Yeah.
Okay, if you are ready, you can start. You can share your screen. You have 10 minutes to present your study.
Okay. Excuse me, is it clear? The PowerPoint?
Yes, we can see your screen. You can start.
Okay, my article title is Parameters Extraction of Miniaturized Metamaterial Unit Cell at Millimeter Wave Applications. I am Huda Aqil Tayyar. I'm a PhD student at Electrical Engineering Department, College of Engineering, University of Mosul from Iraq. And with my supervisor, Dr. Yassar Azzuddin Muhammad Ali, from Department of Computer and Communication Engineering, College of Engineering, Nowruz University from Duhok, Iraq. As an abstract, a metamaterial, which is denoted as MTM, is an artificial structure with electromagnetic characteristics which are not available naturally in any other materials. So in this paper, a wide band metamaterial, it's approximated about 1 gigahertz, miniaturized size and double negative properties has designed for millimeter wave frequencies to achieve metamaterial properties. The permittivity, permeability, refractive index, and impedance have been extracted using retrieve robust method from the reflection coefficient and transmission coefficient. Actually, the simulation results revealed that the proposed MTM unit cell attains the lowest loss and double negative nature DNG at resonant frequency, which is 28 gigahertz. We can collect the applications that utilize the metamaterials as friction, transferring the energy with sensoring, beamforming, absorption, emission, and transmission, and specific absorption rate, SAR reduction. Also filtering, intelligent lenses, FSS, it means the frequency selective surface, bandwidth improvement, and the application which utilize the millimeter wave application and terahertz application. In this paper, a low profile and compact size, rectangular shaped, double gap or split in dual rings resonator is proposed, which is perfectly operate at millimeter wave band, especially resonant frequency 28 gigahertz. The figure shown is illustrate the metamaterial MTM unit cell structure. It consists, as I said before, a double ring or dual ring resonator with double gap. The one gap is the opposite, the gap in the inner ring located in the opposite direction of the outer gap in the outer ring. So the dimension of this unit cell structure illustrated in the table as shown in this slide. So first, a double ring with two split, one at the opposite opposition of the second, is analyzed and simulated to extract the metamaterial properties. So we have here the substrate length 2.31 millimeter. All the dimensions are in millimeter units. 2.44 is the substrate width and outer ring length 2. Outer ring width is 2.2. The gap of inner ring and the outer ring, which is denoted as G1 and G2, are equal to 0.1 millimeter. Also, the width, this S, the width of the strip is 0.1 millimeter also. We have also the space between adjacent rings is 0.4. Substrate height is 0.33 and SRR thickness is 0.035 millimeter. All these dimensions we obtained after optimization. Optimization, the dimension of metamaterial unit cell structure in CST, computer system simulation. So the gap or split, which is denoted as G1 in the outer ring and G2 in the inner ring, are responsible for the capacitance of the SRR structure. What is the meaning of SRR? SRR, I mean the split ring resonator. While the copper strips of the SRR creates inductance. So the mutual coupling between the total capacitance CT with the total inductance LT will generate the resonant frequency of the structure. The resonant frequency shown in this formula. This frequency is equal to 1 over 2 pi square root of LT multiplied by CT. What is LT and CT? LT is the inductance, total inductance of the metamaterial unit cell, and CT is the total capacitance of the unit cell. As I said before, we try to extract the metamaterial properties, which are permittivity, epsilon r equal to n over z, permeability n multiplied by z. So what is n and z? N is the refractive index of the material, is the refractive index. N is dependent on the S21 and S11. S21 is the transmission coefficient of the structure. S11 is the reflection coefficient of the structure. All these parameters we can extract it from the CST technique simulation, studio simulation techniques. And finally, Z, the impedance of the unit cell, it can be given as the formula, and it depends also on S11 and S21. So the waveguide force and boundary conditions are assigned in this figure, in this shown figure. The waveguide and the boundary conditions are assigned to excite the electromagnetic signal and to extract the effective parameters of the designed SRR unit cell. In this figure, it is obvious that the direction of the perfect magnetic conductor in the x-axis, this is the blue color, and the PEC, it is the perfect electric conductor on the y-axis in this side and in this side. And finally, the waveguide port, two waveguide port actually, it is port 1 and port 2. The two waveguide ports are located in the Z direction. So the retrieval method to extract the parameters, the method we use it Nicholson-Ross-Wheel formulas are the optimum method to extract the permittivity and permeability from the simulated complex value of the reflection coefficient, which is S11 as the reflection coefficient and S21 as the transmission coefficient. The real and imaginary values of S parameters are then exported to MATLAB to obtain the values of permittivity and permeability. As the width of metal strip increase, actually the resonant frequency, which is denoted as FR, shift to higher frequency. It's also increased. On the other hand, to control the resonant frequency, the gap distance in the ring G1 and G2 can be changed. This alters the mutual coupling between the ring resonators. The other impact parameter is the spacing between the rings, which is quite important to achieve SRR resonance. I mean, this is split ring resonator resonance.
Ms. Tayyar, you have 1 minute to conclude. Please try to summarize your work.
Okay. Reflection coefficient. This figure shows the reflection coefficient, which is S11. S11 is the lowest value, which is minus 30 dB at 28 gigahertz, which is obtained it means that the very low loss we can obtain from this structure. And so it is very useful in 5G application. And this figure shows the phase curve. It crosses the 0 dB at 28 gigahertz. This figure illustrates the negative permittivity, and this one is the negative permeability, all of them at 28 gigahertz. Real and imaginary part of refractive index, this one, the refractive, real part of the refractive index at 28 gigahertz, and that one is the impedance, which is very stable at this frequency. And finally, conclusion, the direct retrieval techniques is used to retrieve the values of permittivity, permeability, refractive index, as well as impedance from the reflection and the transmission coefficient of this proposed SRR unit cell using MATLAB. All this is successfully doing using CST, as we said, and it achieved a double negative metamaterial at 28 gigahertz. The simulated structure has DNG properties with both negative permittivity and permeability. These properties, along with the compact size of the structure and wide bandwidth, prove this SRR to be unique and the promised structure to improve antenna performance at a specific range of frequencies. And thanks for your attention. And if any question, please.
Okay, thank you very much for your presentation. Dear participants, do you have any questions about this topic? I guess there are no questions. We can go on with the next paper. The title of the paper is Design and Implementation of Power Converter Circuit Toward Electrical Vehicle Charging Applications. Are the authors here?
Yes.
Okay, if you are ready, you can share your screen.
Okay. Is it okay now?
Yes, we can see your screen. You have 10 minutes and you can start.
Okay, thank you very much for having us in this conference to present our work, which is design and implementation of power converter circuit toward electric vehicle charging application. This work was done by Fawaz Abdullah and Mohammed Yassin and Firas. Actually, the motivation to go through this work was the increased demand for energy system to provide enough power to different kind of loads like cars and to reduce the load to the main grid. So in this sense, people try to think about the renewable energy. And this is a good choice to go through the renewable energy. But at the same time, still there's a problem, especially like if you have more than one source, there will be a problem that instability of combining more than one renewable energy source. In this work, we propose using a circuit, which is a modified classical model to use the hybrid synchronous buck converter. In this circuit, we will try to combine more than one source, which is the solar cell source with the wind source, to combine them together to produce a regulated output voltage power. For our proposal, we try to implement a prototype using like the input voltage will be range between 15 to 45 volt maximum. In addition to the power for this prototype will be about 200 watt. And the output for our design will be about 14 volt. So moving to this choice, it's the global trend to use a clean energy instead of using the fuel energy, and this can be useful for the environment. So that's why we choose the PV system in addition to the wind system. So the solution to improve the efficiency by adding more than one source, in case there's a problem or reduction in generation of energy by one source, the other one will be compensated by the second one. So in this prototype, we just use two kind of sources, which is the PV system and the wind system. This figure shows the design for our system, that we have two sources combined by the regulated converter, and later will be stored in the system of batteries. And then this can be used for any application. We suggested this to be used for charging cars. This is the circuit design that we have two sources circuit, and then should be synchronized the pulse width modulation signals applied for both circuits. So we can see that both circuits, both of them have two signals, pulse width modulation 1 and 2, which is applied to the circuit 1 and circuit 2. And then the important condition for this one to be synchronized so they can work at the same time. For this circuit, importantly, that we need to find the circuit components values. The important values for this circuit that we need, the inductor and the capacitor values. So for this circuit, we need to find these values. So we try to put our target for this one, which is the duty cycle for working to be 50%, and the switching frequency for this circuit designed to be about 50 kilohertz, and the load which will be connected to this circuit about 20 ohms. And based on these values, we try to use this mathematical model to extract the values for inductors and capacitor. And after that, we found the values about, for the inductor, about 75 microhenry, and for the capacitor, about 460 microfarad. This slide shows the sub-circuits that we use to implement the whole circuit. So we can see that in circuit number 1, that is the voltage regulator, which can provide different voltage that like 3.3 volt and 5 volt and 12 volt. Circuit number 2, sorry for that, but it's a little bit small due to the slide size. And the second one is the buck converter circuit. Circuit number 3, which is the feedback circuit that will be connected from outside to the microcontroller, which will give us the indication about the output voltage. And number 4, which is the LCD, which can provide a monitoring approach for our circuit, and which will be seen later on the real circuit. Number 5 shows the MOSFET drive for this circuit, and number 6 will be the current sensor with op-amp, which will give the also connected to the microcontroller to give the indication about the current of the circuit. And finally, the circuit number 7, which is the microcontroller circuit, which is the heart for this circuit, which will provide the pulse width modulation signals in addition to controlling the feedback and all the other stuff. Here are the details that I mentioned. So here we can see the printed circuit. Here the design by software, we can design the printed circuit for our proposed system. And here we can use the simulation to simulate the whole components for our circuit. You can see each component and the position and the real size, which will help us to design and print the real circuit. And this figure shows the real implemented circuit after we connect all components and soldering them together and get the final, which is the same I mentioned before, using the LCD, the microcontroller, the drive, all other components. All details are shown here for the components we use in our circuit, and all values based on the calculation we have done. This figure shows the real system under test that we use 2 different sources and as an input voltage to our circuit. And then we can see that the output voltage is constant, even though the input is slightly different, which is about 0.1 volt. You can see that the output is constant at 14 volt, which is the target voltage we choose in this design. So this is very sensitive for any change in the input at 0.1 volt. You can see that the output voltage is still constant at 14. So to sum up all of the points that we have, that this circuit was tested on variable input voltage ranging from about 15 to 45 volts, and the result was the same at the output, about 14 volts, and kind of constant voltage at the output. And you can see also the capacity of for the circuit as shown in table 2. And we achieve that high efficiency using this proposed system to be about 94% compared to the classical circuit. To conclude all of the point that this system provide a solution for instability by using more than one source that can provide stable and regulated output voltage, even though we use more than one source as input voltage. And for this one, we use solar and wind sources to compensate each other when there is a problem for one source. And this can be useful for different applications, especially for electric cars. And this is the classical circuit, and thanks for listening.
And thank you very much for your presentation. Dear
Thank you.
participants, are there any questions about this presentation? As I can see, there are no questions. We can move on with the next paper. The title of the paper is Color Image Encryption Using a Sign Variation of the Logistic Map for SBox and Key Generation. Are the authors here?
Yes, that's me.
Okay, if you are ready, you can share your screen.
You see my screen well now?
Yes, we can see your screen and you can start.
Okay, fantastic. Good afternoon, everyone. My name is Yusuf Korayem. I'm a bachelor's student at the German University in Cairo. I present here the research I've completed in collaboration with Dr. Wasim Alexin and Mr. Engineer both also of the German University in Cairo. This presentation is titled Color Image Encryption Using a Signed Variation of the Logistic Map for SBox and Key Generation. And as the title implies, it concerns a variant of the logistic map and its application in a color image encryption algorithm. This presentation is primarily split into three parts. First, we'll discuss the mathematical constructs used in the encryption. We'll then investigate the specifics of the proposed scheme, and then end with a short discussion on the performance of that scheme and its actual capabilities, as well as examples of its operation. The encryption algorithm operates using three unique mathematical constructs. First, we have the sign variant of the logistic map. We second use a cellular automaton governed by Rule 30, as well as its usage in generating a pseudo-random number generator. And finally, we have an additional SBox, which we've adopted from previous research. First, we have the titular component, the sign variant of the logistic map. When it comes to chaotic functions, the logistic map is generally seen as the most basic source of chaos. The logistic map is defined here, a recurrence relation that relies on the product of the previous value and 1 minus itself, multiplied by a scaling factor to produce the next value. It's only when employing the appropriate scaling factor alpha that chaotic behavior can be observed from this relation. Since the logistic map has been much researched in the field, we've instead applied a small change to the original recurrence, taking the sign of xt instead of taking it directly. The sign adds additional complexity in the computation, which can make brute force attacks slightly slower, as well as changing the acceptable domains, altering the standard alpha values that produce chaotic behavior. To ensure the chaotic nature of this variant, we've plotted the bifurcation and Lyapunov exponent plots of the new recurrence and found suitable chaotic behavior at acceptable values of alpha. Using this, random sequences of values can be produced. We can effectively use the sign logistic map as a pseudo-random number generator. In the presented application of this map, we apply a secondary value, which we call seed, to shift the taken values produced by the logistic map and avoid overlap between different calls of that logistic map to generate random values, as well as add some variance to different implementations. However, it's possible that a different application in another encryption scheme might also utilize different initial values for X in the recurrence, adding additional complexity to that system. Now, with a pseudo-random number generator in hand, we can generate an encryption key of the same length as the required bits in the input image. We can also use the newly generated values to build an SBox, which gives us the ability to permute the values in the encrypted image later on. This is done by mapping the values generated by the altered logistic map from 0 to 255 and removing the duplicate values, dynamically generating a matrix by which we can permute subsections of the source image bitstream. Here is one example of an SBox we've generated using the sign logistic map. For this SBox, we've used the scaling factor alpha of 4.16 exactly, and we've shifted the values, or we've used a shifting seed value of 100. However, to add additional complexity to the final encryption scheme, we've also adopted the usage of a secondary SBox, which we've generated using the research mentioned here. The specific SBox we've applied during the examples is presented here. Although obviously the research that they produced indicates different methods by which an SBox may be dynamically generated, but for the purposes of the examples we'll discuss later, this is the SBox we've used. The final mathematical construct, or actually before we get to that, we'll discuss a little bit of the comparison between our SBox, here presented as SLM, and the SBox we've adopted, here presented as adopted SBox. These are some commonly used SBox comparison criteria, including non-linearity, standard avalanche criterion, and bit independence criterion. As we can see, the dynamically generated SBox doesn't exactly perform optimally, nor does it perform quite as well as other SBoxes, but it performs acceptably, especially considering that the matrix is generated dynamically and the implementation for it is very fast and light computationally. The final mathematical construct we've used in the scheme is the Wolfram cellular automaton. Without going into too much detail, cellular automata are recurring systems that can generate long lists of values by applying certain rule sets. Some of these rule sets, including the Rule 30 set we've applied here, are shown to behave chaotically, which we've thus adopted for our implementation, especially given that they require an additional input variable, a seed, to initialize this implementation. In essence, the algorithm does the following, which we can also show in the form of a flowchart. It takes an input image and then converts that input image into a raw stream of bytes, which are then XORed with an encryption key in the form of a secondary stream of the same length that we generate using the sign variant of the logistic map. This is done given the input variables that we've discussed earlier, which are the scaling factor, the shifting value of the sign logistic map. We then apply a permutation operation using the SBox we've generated from the sign logistic map as well, thus permuting the contents of subsections of that encrypted scheme. This is an SBox that is also generated using another two variables, which are a secondary scaling factor and a secondary shifting value to avoid too much overlap between the contents of the key and the SBox. This is followed by XORing. This time we're going to use a secondary key, but generated using the Rule 30 cellular automaton. We then follow this with another round of permutation using the SBoxes generated by the research we've adopted earlier. From this, we see that we have completed our encryption, and thus we reshape the image data to form a normalized image, and then we can transfer it and use it as our output. Here are a few examples of operation using sample images taken from the University of South California's image processing library. Here we can see that the encrypted images don't reveal any information about the source, at least to the human eye. They're completely dissociated from each other. We can also see that the color distribution histograms are very much normalized in the encrypted version when especially compared to the original image. This is very useful to us because modern attackers and those seeking to break image encryptions will often rely on the fact that image data has very unique color distribution schemes. And so they might use statistical cryptanalytic techniques in order to break through and recover some of the contents of the original image. Here are two other examples, one using the tree image and one using the house image. However, to ensure that this encryption is actually resistant to machine attacks, we've also performed several rounds of analysis on the encrypted images and compared them to other research similarly performing image encryption. For MSE and PSNR tests, we see that the proposed algorithm performs similarly, if not better than similar algorithms in research. This shows that the contents of the original image and the contents of the encrypted image are very much dissociated from each other, even on a machine level, just beyond the human visual system experimentation that we showed earlier. We can also say the same thing about entropy rates. Entropy rates are quite high, approaching the ideal value of 8 and performing similarly to the other research provided. Now, one major advantage of this specific implementation is its high speed of operation. Even the largest images, shown here at around 1024 by 1024 pixels in dimension, exceed some of the performances provided by similar research. We can encrypt a whole image at approximately HD in 1.3 seconds, which is very useful because of the increasing sizes of images in modern data transfer. And this makes it definitely fast enough for real industrial applications. It should be noted, of course, that the real applications of this scheme assume initial secure transmission of the seed values for the sign logistic map for both the key generation and the SBox creation, as well as the seed values for the cellular automata. All of this is done in advance, which are then used to generate the encryption keys at both the sender and receiving devices. These values can be taken to very high levels of precision. Earlier, we showed that we generated an SBox and we also generated similar keys using a scaling factor of 4.16. You can take this up to 12 decimal places of precision to add even more precision. And due to the chaotic nature of these functions, this will provide very little similarity between values at high levels of precision. We've also gone ahead and applied the NIST randomness statistical suite of tests to one of our encrypted images, in this case, House 2, specifically to get an understanding of just how random the produced encrypted images are. All tests were passed, which implies that at the very least, an image encrypted by our algorithm returns a stream that looks very much like a random stream of bits. This was the encryption scheme that we proposed. We formulated a new chaotic function and showed its effectiveness in making an encryption algorithm which operates quickly and effectively. It has performed quite comparably to other research on PSNR, MSE, and entropy tests. We've also shown that our scheme performs these encryptions incredibly quickly, making it useful for industrial applications. We'd like to recommend that in the future, similar research investigate tweaking our method of generating SBoxes to make SBoxes that are more effective and efficient in time, as well as gaining more benefit from the PRNGs that we discussed, as well as the possibility of using an additional SBox or two for added security. Here are the sources that we've used when it comes to the comparisons with other research. We thank you for your time, and we'd love to take any questions.
Thank you very much for your presentation. Dear participants, do you have any questions about this topic? Okay, I guess there are no questions. Thank you again. We can go on with the next paper. The title of the paper is Research on Speech Synthesis Based on Prosodic Controllability. Are the authors of this paper here? I guess the authors are not here. And we can go on with the other paper. The title of the paper is Impact of Technology Use on Frontline Supervision Practices in the Construction Industry. Are the authors here?
Yes, I'm here.
Okay, you can share your screen if you're
Okay.
ready.
Good morning. My name is Bassam Ramadan. I'm from the University of Kentucky. I'm a PhD candidate, and I'm presenting this research on behalf of my colleagues. This paper will discuss the impact of technology use on frontline supervision practices in the construction industry. The main research question we're trying to answer here is, how do frontline supervisors spend their time, and how does technology use impact time spent on different tasks at in the construction industry? Why is this important? We know that supervisors play a crucial role in construction projects, and they have essential responsibilities from managing workers and resources to creating a link between management and workers. We also know that low productivity is more often the fault of supervisors instead of construction workers. There have been multiple studies that have found that low productivity is due to inadequate supervision. And despite the acknowledged importance of foremen and frontline supervisors, their role has often been overlooked and not given the attention it deserves. Finally, technology used on site has been shown to improve productivity and efficiency. And while we know that the literature has highlighted the importance of frontline supervision and technology use on site, no research yet has studied how the use of different technologies can affect frontline supervision practices in the construction industry. In order to address the research question, we sent a survey to frontline supervisors, and we asked them about their time distribution practices regarding how they spend their time during their day, and we asked them about possible technology use on site. We identified the technologies that they use on site. We grouped the data based on technology use. We calculated the average percentage of time spent on each task for each group. We compared averages of percentage of time spent on each task based on different technology use. And finally, we performed statistical testing, mainly the Mann-Whitney U-test, to investigate if any difference between groups that where technology is used and groups where technology is used is statistically significant. The survey received 2,740 complete responses. Those were included supervisors and construction workers. So we isolated supervisors for this study, and that included 1,062 supervisor responses in the construction industry. This map shows identified the location of all the respondents, and as we can see here, most of the respondents came from all 50 states across the United States, and most of the respondents came from the Northeast, the main cities in the Northeast, cities in California, Texas, Illinois, and Florida. If we break down the survey respondents by their demographics, we know that 31% were foremen, 29% were superintendents, 17% were general foremen, 2% were craft superintendents, and 2% were assistant superintendents. If you look closely by age, we can see that 33% are over the age of 55, 33% are in the 45 to 54 age group, 25% are in the 35 to 44 age group, 8% are in the 25 to 34 age group, and 0.3% are under the age of 25. We asked construction supervisors in the survey to allocate the percentage of time they spend on each task. And in the survey question, all these categories had to add up to 100. So the list of different tasks that were listed included supervision tasks, administration tasks, planning tasks, training workers tasks, and they were allowed to list any other responsibilities they do that they could list. We also asked them if each of the following technologies are used on site. We asked about 3 different types of technologies. Among information technologies, the list included barcode scanning, virtual or augmented reality, RFID chip tracking, building information modeling, artificial intelligence, robotics, and drones. Among material technologies, the list included prefabrication or modularization and quick connection systems. Among equipment technologies, the list included autonomous machinery, battery-powered tools, new hand tools that were developed in the past 5 years, and new construction tool machinery that was developed in the past 5 years that we were able to list in the questionnaire. This table shows the results of the average percentage of time dedicated to supervision tasks among supervisors based on whether a technology is used on their site or not. Here we can see that only 2 technologies had a statistically significant impact on the amount of time spent on supervision tasks. And those 2 technologies are prefabrication and modularization and battery-powered tools, where when these 2 technologies were used, supervisors had spent statistically more time on supervision tasks compared to colleagues where this technology is not used. The following table shows the average percentage of time dedicated to administration tasks among supervisors based on whether a technology is used or not. And as we can see here, there are only 3 technologies where the use of a technology had a statistically significant impact on the time spent on administration tasks. And those technologies include building information modeling, prefabrication and modularization, and battery-powered tools. And for all 3 of these technologies, supervisors where those technologies are used spent more time on the administration tasks compared to their colleagues where the technology is not used. The following table shows the average percentage of time dedicated to planning tasks among supervisors where each of the following technologies is used or not. As we can see here, 7 technologies had a statistically significant impact on how much time supervisors spend on planning tasks. When we look at artificial intelligence, that was the only technology that had a statistically significant impact where supervisors spend less time on planning tasks compared to, however, if we look at RFID chip tracking, drones, quick connection systems, autonomous machinery, new hand tools, and battery-powered tools, the supervisors who use those technologies spent more time statistically on planning tasks compared to their colleagues where that technology is not used. Finally, this table shows the average percentage of time dedicated to training tasks of other workers, where we can see that 8 of these technologies are used, there were statistically significant impact on how much time supervisors spend on training tasks. If we look at barcode scanning, virtual or augmented reality, RFID chip tracking, artificial intelligence, robotics, drones, robotics, prefabrication and modularization, new hand tools, when all of these technologies are used, supervisors tend to spend more time on training tasks compared to when to their colleagues of supervisor when that technology is not used on site. However, when battery power tools on site, statistically, they spend less time on training tasks compared to their colleagues. Finally, this research hopefully will serve as a basis for future research. We will aim to analyze how technology and task time distribution will impact worker and supervisor performance within the construction industry. And we will attempt to identify the optimal time allocation practices for supervisors as a roadmap to increase field productivity. Thank you for your time. If you have any questions, I would be happy to answer.
Thank you very much for your presentation. Dear participants, are there any questions about this topic? Okay, I guess there are no questions. We can go on with the next paper. The title of the paper is a symmetric TDMA mechanism to optimize the performance of the body sensor network for sports application. Are the authors here? I guess the authors of this paper are not here. Then we can go on with the next paper. The title of the paper is Quantum Signal Analysis Combined to Artificial Intelligence and Green Sustainability, a Protocol of Feasible Rules. Are the authors here?
Hello, can you hear me?
Yes, we can hear you.
Hello.
You can share your screen.
One moment, please. One moment. Can you see my presentation?
Yes, we can see your presentation. You can start. You have 10 minutes to complete your presentation.
Thank you, first of all, for giving us the opportunity to participate in this conference and presenting our work. I'm Kostas Pepes from the University of Peloponnese, and the work under presentation is titled Quantum Signal Analysis Combined to Artificial Intelligence and Green Sustainability. So, the purpose of this study is, first of all, to mention some scientific nature provocation of the quantum theory and the stages that led to its formation, to demonstrate and innovate towards providing the basic principles to give meaning to the so-called quantum signal analysis, to provide a preliminary protocol of basic rules that present how to encompass implementation with proper classification. Moreover, to provide an AI scheme to combine with the proposed protocol for general use, and finally to show the resulting quantum AI scheme can more sufficiently serve green technologies. So, traditional signal processing can be used for optimizing transition to correct disordered signals, find points of interest through various signal measurements, and this technology has matured through the 60s and 70s, while in the 80s has been strongly associated with signal processing devices, DSPs. As well known, there are various kinds of signal processing, such as continuous time, discrete time, and analog signals processing. Also, there is statistical signal processing that treats signals as stochastic processes and can be used efficiently to provide enhanced significant techniques. Another issue is that we can have quantum simple processing, which is based on the axioms of quantum physics, and this can treat an algorithm for simulate a Hamiltonian system under test. So let us imagine a mixed quantum signal processing with the design of an artificial intelligence systems which can lift off the range of artificial intelligence consciousness, as this will include various iterations ranging from quantum dimensions to a macroscopic level. Additionally, we can have we propose a future implementation that will light the potentialities of future development in every aspect of science. The proposed AI scheme consists of an iterative system of 3 levels, where the first level checks the suitability of the application, conducts detection, prognosis, development, self-calibration, continuous monitoring, construction, and the use of neural networks. The second stage is the machine learning pipeline, which includes iteration techniques and pathetic judgment for a better understanding of each situation. Then we have a third level, which includes the awareness of the present and past conditions, processing of real-time data, and to establish the metamenority. Now, as far as the basic rules of quantum mechanics are concerned, the quantum mechanics, the traditional physics is a well-established science and is based on Newtonian mechanics, electromagnetic Maxwell equations, thermodynamics, and relativity. There is the quantum mechanics, which have wave theory and quantities that are not associated with bodies or particles. The gap between wave and particles conceptually is a research, but mathematically speaking, there are the well-known of Max Planck and Louis de Broglie that associate the energy through frequency, see for example equations 1 and 2, and the wavelength with respect to momentum of the body. However, in quantum mechanics, physical systems are governed by the so-called Schrödinger effect, which is the fundamental line of the theory, and a similar fashion as the Newton mechanics and the Maxwell equations for electromagnetism. Laplace's equation is not proved, but it has been verified experimentally. Specifically, in a class wave theory, a wave with an angular frequency of 1 and wave number of k is a plane wave which can be described as an exponentially complex function described by equations 3 and 4. Now, after performing some steps, we can reach the Schrödinger equation, which is described as a system, okay, which gives specific quantum states. See equation 5. In general, the problem is intensified by the fact that the wave function is experimentally unobservable. This matter has been solved by Max Born verifiable statistical theorem, which considers that the magnitude of square of a wave function declares the probability density of finding the particle in a specified region of space. And Born himself recognized this point of view as an arbitrary inversion, but it has been verified by all experimental data. Another issue is that eigenfunctions can be treated as vectors, and they are maybe orthogonals, which where the inner product of the functions defined by equation 7 is given by this equation, and the eigenfunctions of a system which results from the solution of a Schrödinger equations are orthonormal. Every wave function constitutes a state vector, and each eigenfunction is an eigenvector of a Hilbert vector space. So quantum theory is distinguished as from line of 5 axioms. First, the state is completely defined by a wave function. The second is that for every system property in classical mechanics, for example, position or energy, they can be replaced by a suitably defined operator. The third is that for any measurement of a property corresponding to the operator, the only values are eigenvalues of this operator. The fourth is that if a system is described by wave function and the value of the property is measured 1, then the average value is given by this equation 8. And finally, the time evolution of a quantum mechanical system is given by the time-dependent Schrödinger equation. Now, let us associate the quantum signal analysis. So the science of signal and image processing works because this scientific area processes signals such as universal response of object to perturbation while ranging from galactic interstellar phenomena to central nervous system. Moreover, all the integrated software can be based on fast Fourier transform despite the ability of many processing methods. Moreover, we have the standard Padé approximation, which is vastly studied subject to provide rational approximation of the impulse response of a specific system. Moreover, we have an autocorrelation function, ACF, which have initially constructed experimentally or theoretically to obtain a mathematical expression for the received signal. So the concept of autocorrelation is appeared as computational tool, but it has been performed its original purpose to support an alternative formulation of quantum mechanics. For example, many observable facts such full energy spectra, local density of states, quantitative state evolution constants, and other quantities can be expressed through autocorrelation functions and from appropriative transformation.
Sorry, you have 2 minutes. Please try to conclude and summarize.
Okay, so let us see some protocols. We propose an AI-based design of the protocol. So this is based on a 3 level. The first level involves 6 sectors. First, the suitability of the LED building for inhabitants, to set the primary values for initiating quantum signal analysis, to detect prognosis of resident and flawless operation of the environment, to add self-calibration, to continue monitor of spaces, and to the use of neural networks for enhancing the accuracy, if possible, for using the quantum protocol. Every sector relies on machine learning techniques, and there are 6 major categories, which include goal definition, data acquisition, preparing of data, training procedures, and running model. The 5th category are the items obtained from the axioms of the quantum physics, and the 4th category, we use an empathetic mechanism to combine mathematical lessons with quantum analytical expression and a digital humanized system. So there are 8 stages knowledge comparing systems past and present condition, data processing, new comparison of stages 2 and 3, supporting current and future data, meta memory, primary case sensitive details, and quantum versus conventional AI logic. So some conclusions: we have proposed an AI design that includes quantum analytical expressions taken from the PR110 protocol. The limitations are that only custom design has implemented a certain time of system, and this design should be thoroughly tested in real-time conditions to find a system drawback and enhance its performance. Or we can use quantum analytical expression to compare with other algorithms in real-time conditions to find its real value in supporting AI. This research includes the study of quantum theory with quantum signal analysis to identify analytical candidates to use an advanced AI system that employs empathy. And we can achieve that because an advanced quantum system is proposed. This kind of system with proper alteration can surely benefit research areas such as medicine and clinical science, which will be the next target of this implementation. Thank you, and sorry for the long time of the presentation.
Okay, thank you very much for your presentation. Are there any questions about this presentation? As I can see, there are no questions. Thank you again. We can go with the next paper. The title of the paper is The Investigation of Skin Effect in Tissue, the Estimation of the Electromagnetic Risk Interference with Living Organisms. Are the authors here? I guess they are not here. The same author has another paper, and I will not announce it. We will go on with the next paper. The title of the paper is A Review of the Application of Machine Learning in Home Automation. Are the authors here?
Yes, we're here.
Okay, you can share your screen if you're ready.
Yes, just a second. Yes. Can you see my screen?
Yes, we can see. You can start.
Okay, thank you. The paper I'm going to present to you is called a review of the application of machine learning in home automation. Me and my colleague, Irena Vova, are from University of Ruse, Bulgaria. Many researchers are considering the idea of using different various algorithms for machine learning, for artificial intelligence, deep learning, to observe the human behavior, to find patterns in human behavior, and make various predictions about the needs of the users, of the home owners, as well as to control the system based on different classification, different rules, patterns, and so on. And in the past few years and in the several next year, is expected this trend to grow even more. Here in this graph, in this diagram, you can see the number of smart homes, some kind of smart home automation in 2019 and up to the next few years. From here, the several few slides are our review on different systems, on different authors and their systems and proposals. The first one is a smart home automation using IoT and deep learning. This is a smart home system with a deep learning algorithm that recognizes human activities based on data provided by several wireless sensor data mining lab. The data set consists of different data taken from a smartphone, which smartphone is attached to people's waist while performing various activities. And the algorithm used in this system is LSTM. Another system by different authors, smart home automation using machine learning algorithms, is an improved home automation system using multiple machine learning algorithms. The system can detect facial expressions and adjust the home environment based on these facial expressions. And here the algorithms used in this system by those authors are CNN, Fisher face classifier, and support vector machines. In machine learning on real-time data to enhance home automation, the authors are exploring two very well-known techniques of home automation. The first one being the centralized electronic control-based centralized hardware that provides control in information to the user by some kind of application with interface. In those types of systems, the main aim is to control the home appliances remotely via Wi-Fi, via internet. And the second type of system is called a simple reflex agent-based system. In home automation with machine learning for activity recognition, the authors are proposing a system that aims to recognize user activity patterns using deep neural networks. And the hardware is Raspberry Pi with different sensors, PIR sensor as well. The authors are concluding that deep learning helps to reduce the dependence on human factors when extracting features for pattern recognition, and thus making some rules, some classifications for home automation. Here, the algorithms are LSTM and RNN. In another proposed system, in another review called Home Automation System using IoT and machine learning techniques from 2020, the authors are proposing a small IoT-based system for home control based on face detection. They are proposing the idea of using different cameras to capture the faces of the users that are entering the home, the building, and transform those input video streams. The algorithms used in this system are AdaBoost, Eigenfaces, and Fisher faces, as well as the previous some of the previous systems. In automated learning and decision making of a smart home system, the authors are proposing that after at least one day of data collection from several sensors, a random forest model is used to predict the behavior of the system. And new data is evaluated every minute or when a motion sensor detects some kind of movement or some kind of change. After the classification of the action that the system has detected, the whole system predicts the needed action based on this action that is performed by the users, by the people in the home. And for example, if the state of one device is changed, the system checks if the states of any other device should be changed as well, should be reconfigured. The algorithm used in this system is random forest. Different type of system, an interesting one, audio system for emergency classification from 2018. This is a system for classifying home audio sounds. It uses audio sensors that are capturing the sounds in the home and are sent to a recognition server, some kind of centralized server that performs feature extraction, analytics, and classification as well. And the classification and in the system, in the whole system itself, aim to detect violence and send alerts to emergency centers. And that's actually one very useful feature of this system. The algorithms used in it are CNN, LSTM, support vector machine, random forest, decision tree, and naive Bayes. This system is actually one of the systems that has the most machine learning algorithms implemented in it. Another one is called Intelligent, Secure, and Smart Home Automation System from 2020. This is a smart home automation system that allows the user full control over their home appliances via a mobile application. The system consists of a Raspberry Pi. Actually, many of the systems reviewed in our paper are including some kind of Raspberry Pi board for data gathering. And this one uses a cloud server for storing and managing both the user information and the home appliances. In terms of security, this system uses blockchain technology implemented in the process of user authentication. And this system actually was the only one that uses such type of technology, at least from the systems we have reviewed. The algorithm used in this one is support vector machines. Another one is recommender system for home automation using IoT and artificial intelligence. It uses audio commands from a user and with the help of natural language processing, controls home appliances such as door monitoring, home appliances monitoring, bed movement, and etc. The main target users are old and disabled people who cannot control their homes by themselves, completely by themselves, but can control their homes with the help of such system of the proposed system. Here, the algorithms have not been stated, and we actually don't have information about the machine learning algorithms that are used here. Another one.
Sorry, your time administration is over. Please try to summarize and
Yes,
conclude the
yes.
work.
The last one is this one. In conclusion, 10 proposed systems for home automation with machine learning are examined. And what is notable is that the hardware components are often a Raspberry Pi and several different sensors. And in many systems, there is some kind of interface. In many systems, the usage of machine learning is mentioned, but there are no further details about the ways of application, about the ways of development, implementation, or any of the tests that are made with the system. And some of the systems are ideal for home automation systems, but have not been developed or tested and are on the prototype phase. Thank you for your attention, and if you have any questions, I am happy to answer them.
Yeah, thank you very much for your presentation. Dear participants, do you have any questions about this topic? Okay, I guess there are no questions. We can go on with the next paper. The title of the paper is Electronic Voting Through Blockchain, a Survey. Are the authors here?
Hello, yes, I'm here.
Okay, you can share your screen if you are ready.
Perfect. Hello. Can you see it?
Yes, we can see your screen. You can start.
So my paper is called Electronic Voting Through Blockchain. We conducted a survey, a literature review of the current solutions, and published papers for electronic voting. My name is Antonio. I produced this paper together with my professor, Carlos Coutinho. He's not here today, but I will do the presentation. And thank you for this opportunity to speak in this conference also. So, introduction, a little bit about why we chose this paper and this topic. We have seen increasing number of cyber attacks in the past few years with COVID, a lot of digital activity, increase of digital activity in this, in everything. And in relation to electronic voting, we have seen that most electronic voting systems do not have the trust, even though we have some places in the world where electronic voting is the norm, like Brazil and Pakistan. And a lot of these electronic voting systems have no way of being audited, not by the public, so you have to rely on a third party, trusted third party to audit it. So our goal is to show some of the blockchain capabilities and here in these systems. The objective of this paper is to review proposed frameworks and proposed solutions done by other authors and evaluate their proposals, see what tools they are using, types of encryption, and what are the flaws and future work that they suggested. A little bit of who is using electronic voting today. One of the most countries that are using mostly electronic voting is Estonia since 2008. Estonia and Australia also provide internet voting, so you can vote actually online. And Brazil and Pakistan actually utilize electronic voting machines, so you have to go to a proper place and cast your vote in an electronic machine. About our paper, we did conduct a literature review, utilizing the main keywords of blockchain and e-voting, and we proceed to these 4 filters to get the proper articles. We filtered articles that only have been through higher quality conference or journals, and later I read these papers and concluded if they evaluate some type of solution, if they are a solution, if they are inside the terms that we want for this paper. This is the data from our survey. So we had in the end 25 papers and utilized these online databases. So IEE, ACM, SpringerLink, and Wiley, and we can see the data from the conferences and journal rankings. A little bit of the sample that we have, we can see we have mostly conference papers and some journal papers, and we can see the increase of publications by year. So lately we can see the increase of interest by blockchain and e-voting. When reading the papers and then surveying the articles, we analyze if that has an application proposal. It analyzes performance, if it evaluates its own proposal, if it says the tools they are using, and if they evaluate the limitations of open source. Is what we wanted to get out of this survey. And a little bit of the results, we can see that most proposals are done in the Ethereum ecosystem. So we can see Ethereum maybe using smart contracts directly in Ethereum, using even some other types. We can see Get, which is the first implementation of Ethereum. We have some proposals that, and included in the Ethereum ecosystem is the side chains and off-chain solutions, layer 2 solutions that provide more scalability, and some of the solutions that we see. We can see most of the solutions that we found are made with Solidity and smart contracts on a layer 1 solution. These solutions provide a lot of transparency and they work fine, but they are really limited on scalability. So you could never run a countrywide election with a layer 1 solution. And the layer 1 solution also have problems with privacy, voter privacy. So you cannot your address and who you voted. Most times it's public and everyone can see who you voted. And the layer 2 solutions have been moved to more, how can I say, flexible in the terms of their solutions. Layer 2 solutions, you can use some other side chains that offer more privacy, and you sacrifice scalability, or you have more scalability and sacrifice a little bit of privacy or decentralization, which is one of the things that we highlighted. It's that a lot of layer 2 solutions provide great scalability, but then you don't have the decentralized system that you want with the blockchain solution. We also had a permission blockchain, and Hyperledger solutions were very flexible, but these blockchains are not public, so everyone will have to have access to that proper blockchain to see, run, provide, see the results, and have the cast their votes. In your conclusion, the biggest problems that we have seen in the blockchain voting systems are security, privacy, and scalability. The most promising solutions were layer 2 solutions. These layer 2 solutions are evolving rapidly, and we can see how they provide features to increase privacy, increase scalability. In the future, we can see probably a suitable solution to run a countrywide election in a layer 2 Ethereum solution that will provide the voter anonymity that we look for, and the scalability that we need. In question of the analysis of the papers, a lot of papers showed security vulnerabilities. One of the most common security vulnerability was the transaction malleability, and these types of vulnerabilities could exploit votes, maybe in the voting phase or when people are casting votes, and this actually would break the solution. That's it. Thank you very much for letting me present my work.
Thank you very much for your presentation. Dear participants, are there any questions about this presentation? Okay, I guess there are no questions. We have actually 4 more papers, but the authors were not here. Once again, let me announce them. The title of the first paper is Research on Speed Synthesis Based on Prosodic Non-Triviality. Are the authors here? Okay, they are not here. The second paper is a symmetric TDMA mechanism to optimize the performance of the body sensor networks for sports application. Are the authors here? Okay, they are not here. Other paper is the investigation of skin effect in tissue, the estimation of the electromagnetic risk in interference with living organism. Are the authors here? Okay, they are not here. And the last one is the mapping of electromagnetic field of machine tool for assessment of its influence on the pacemaker. Are the authors here? As I can see, the authors are not here. And now I would like to end the session, and I would like to thank all participants for their scientific contribution to the Congress. Now I am ending the session. Thank you very much. Sorry?
Yeah, the V3 for the 5 p.m. Is this the room that is ongoing now? Please.
I can't hear you. Can you repeat?
I'm asking if the V3 is this the current room going on now?
Your voice is not clear. Can you write to the chat? Your voice is not clear.
Yeah, the V3.
Can you write to chat?
Yes, it was scheduled for 5 p.m. That's GMT +3 today. Hello, can you hear me?
Yes, but I can't hear you clearly. There's a problem with your voice.
Okay.
Can you write to chat?
Okay, let me write on the chat.
Okay, I'm waiting.
Yeah, I've written on the chat.
Okay, this is not the last session. We have two more sessions at 5 p.m. Those sessions are 12.1 and 12.2, but for virtual room 3, we have one more session, and it is session 12.2, which will start at 5 p.m. Okay, we have one more session in virtual room 3 at 5 p.m.
Okay, thank you.
Okay, you're welcome. Are there any questions?
No, for now. I'm supposed to be for the next session. So I'll wait till 5 p.m.
Okay, thank you very much.
Thank you.
Again, now I'm ending the session.
Okay.